Hello guys, today we will solve the problem 347 from the Leetcode, which is to find the top k frequent elements. The problem statement is we have an array of integers and we have given an integer k and we have to find the most frequent elements, k most frequent elements. And we can return the result in any order. So if we see the example, in this case, the frequency of number 1 is 3, the frequency of number 2 is 2, and the frequency of number 1 is 1, and the value of k is 2. So two most frequent elements is 1 and 2. So the output is 1 and 2. In example 2, nums is 1 and the value of k is 1. So since we have only one element, that is the, and k is also 1, so that is the one most frequent element. So that is the problem statement. Let's see the approach now. Here is the algorithm. So what we will do is we will build a hash map with the frequency of each number. So for this example, we have 1 with frequency 3, 2 with frequency 2, and 3 with frequency 1. So this will be the value of the hash map. Once we have this map, the step 2 would be to build a min heap of size k based on the frequency of these numbers. Let's see the step 2 for this example. So once we have this map, we will build the heap, and in our heap, the first number will be 1. And then based on the map, we'll have 2, and 2 is having the frequency smaller than 1. So 2 will be on top of the heap. So this is the heap. Now we have the next element 3, and it is having frequency 1. So since this is min heap, based on the frequency, 3 will be on the top. And if you see now, what happened was the size of this heap is 3 and the value of k given was 2. So as soon as the size of the heap exceeds, what we would do is we will remove the element from the top. So the top element will be removed from the heap. So the idea is at any point in time, the total number of elements in the heap should not exceed k. All right. So this was step 2. So right now in our heap, we have 1 and 2. Now let's see what is step 3. The step 3 is fill the output array by pulling elements from the heap. That means now the task is to just get this element, and since we have to return an array, we'll just put these elements in the array. And also the order doesn't matter. We can fill this array in any order. And this is the output. So I hope the approach is clear. Now let's move to the code. We have to return integer array, and these two are the inputs given to us. So in this line, we are scanning the input given and we are building map. In the map, the key is the number and the value is the frequency. So the first time we see the number, we initialize with 1, and if it is already initialized, we are getting from the map and adding 1 to it. So by the end of this loop, we will have the map with the numbers and their frequencies. And this step, we are defining a priority queue, and here is the comparator based on the value of the map. So the min heap will have the value at the top, which is having the lowest frequency. All right. Now, in next step, we will iterate our map and we will add the key in this priority queue. And if we find the size of the priority queue is greater than k, then we will remove that element from the priority queue. So once this line executes complete, we have the priority queue of size k, and that is the output. Like those are the numbers which is the desired output. So since we have to return an integer array, we're defining an integer array over here, and then we are copying all those elements by polling the queue into the result array, and we're returning result. So what is the time complexity for this algorithm? So the time complexity is here order of n, and we are building this priority queue in worst case for n elements. If all the elements are unique, and the size of the heap is k, so the heap operation will be done in log k, and here order of n operations. So the overall time complexity of this algorithm is n log k. And what is the space complexity? The space complexity would be, we have the map and we have the priority queue. So at max n elements, so order of n. Now we can also solve this problem in better time complexity. So it could be done in order of n as well. So I will discuss the other approach in my next video. Thanks for watching this.